Welcome, Algebra 3, to Lesson 61. We're going to do a little bit of data analysis, and we're going to start with single variable analysis, and that's where we just have a single data point that we're looking for. Like in this case, this number line represents the weight of 4 dogs, was just a sample of the number of dogs that were weighed at the vet's office in one day, let's say. So this data plotted on the number line, we can actually analyze the information here and understand the spread of the data, and it will tell us certain parts or certain bits of information once we know how to read it and how to understand it. So the first thing that we should remember is how to find what's called the mean or the average. And we just take the sum of the numbers divided by the number of numbers. So in this case, we have 4 plus 7 plus 9 plus 20, and that's going to be divided by 4. And when we add all of those up, we get 40 divided by 4, and that's going to be equal to a 10-pound average. So the average dog that comes into this vet to be weighed, as illustrated by the weights on a given day, is 10 pounds. So that's our mean. And you see this little funky little symbol here? We use that symbol to indicate the mean or the average of the data. And it just looks like a backwards U almost, or a backwards Y. It's just kind of, you make a little U and then you put that line down the front. And that is just the symbol for mean. Now we know what the range is. The range is the distance that's covered on the number line. And you find that by taking the highest number, subtracting the lowest number. So in this case, that'd be 20 minus 4. Our range is going to be 16. So that's pretty straightforward and understood. Now, the standard deviation, we use that evaluation to tell us the spread of the data. And we get that calculation by, and this is what this little symbol here is, that means standard deviation. And we use that, or we find that by taking the square of the variance. Now, how do we get the variance? What is the variance? Well, first we have to start with what is a deviation. A deviation is the distance from the mean. So we would subtract, we would find the mean, and I'm going to mark it with this blue right here. The mean is 10, that's the average. So what we would do is we would find the distance from 10 that each number has. So from 9 to 10, we have a distance of 1. From 7 to 10, we have a distance of 3. And from 4 to 10, we have a distance of 6. And then from 10 to 20, we have a distance of 10. So those are our 3 distances. So those are our 3 deviations. So to find that variance, we have to take these numbers and make them mean something. So technically, this is behind or to the left, so that'd be a -1, a -3, a -6. And this will be a positive 10 because it's to the right if we use the number line rules, right? With 10, our mean being our point of origin. Now, if we were to just take these all up and add them together to try to find some type of an average, we would get 0 because -6, -3, -1, that is -10 plus 10. That's going to be 0. And for some, it always works out that way. It always works out that way. And if you think about it, the average is going to be smack dab in the middle of all of the values here. So it's always going to equal 0. That's just the way it works. So what we do instead to calculate that is to square the numbers, square the distance, because then that removes the negative sign. And then we find the square root of that distance. So that takes the square off of it. So it is a way to remove that. So what we do to solve for that, we find the variance. We take each deviation and square it and add it to the next one, and then divide that by the number That's our variance. And then to find the standard deviation, we get the square root of the variance. So in this case, our variance is going to be, and I'll just do this out here, it's going to be -6 squared plus -3 squared plus -1 squared plus 10 squared. And all of that is going to be divided by 4 because there are 4 numbers here. So that would end up being 36 plus 9 plus 1 plus 100 divided by 4. So when we add all of that up, we get 146 divided by 4, which equals 36.5. So to find the standard deviation, we would take the square root of 36.5. That would be our standard deviation of this data. And that's going to tell us the spread. And if you put this in your calculator, you find that the square root of 36.5 is equal to 6.04. That would be our standard deviation. And so what that tells us, if we look on our chart, is that we can identify where the majority of our future data is going to come from based on the standard deviation. So let's just practice finding another standard deviation before we apply that to what we call a normal distribution. And I'll show you what that means. So here, let's do a practice problem using all of this. And I hope that you have written all this down so that you can find your standard deviation from finding your variance and what the variance means. So let's do a practice problem. So 61.1, our problem is the measured distances are 12, 7, 15, and 10. Find the mean and the standard deviation. So to find the mean, we're just going to find the average. So 12 plus 7 plus 15 plus 10 divided by 4. And that is going to give us a total of 44 divided by 4, which gives us a mean of 11. That's our mean. So now we can find the standard deviation from, or the deviation from our mean that will give us our variance. So on the number line, just make a little quick number line over here, and we're going to plot. Let's start at 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, that covers the range of numbers that we have. So we had 12, 7, 15, and 10. And our mean is 11. All right, so our standard deviation here is a -1, and that's 1, 2, 3. This is a -4. This is going to be a +1, and this is going to be a +4. And see again, with the numbers that were selected, if you just add the deviations together, you get 0. That tells us nothing. So that is why we square them. So let's find our variance first. So we're going to do -4 squared plus -1 squared plus 1 squared plus 4 squared. And that's going to be divided by 4. So we take these deviations, and that becomes 16 plus 1 plus 1 plus 16 divided by 4. That becomes 34. Yes. 34 divided by 4. Oh, goodness. That's going to be 8.5 when I round it up there. And so that is our variance. 8.5 is our variance. So now to find our standard deviation, we're going to find the square root of 8.5 is going to be our standard deviation, square root of our variance. So the square root of our variance is 2.92 when we put it in the calculator. So that's our standard deviation. So that is the process that we would use in order to find the standard deviation of a set of numbers. First we find the mean, then we find the deviation, then we square the deviations and divide by the number of numbers that we had. That we do all the division. That gives us our variance. This is the variance right here. That's what we're doing. And then these are the deviations, right? So we take our deviations, square them, add them together. Then we find the square root of the variance, and that's our standard deviation. Okay, and we go ahead and we get the square of that. We actually use our calculators now, so you can go ahead and get the final number. Aren't you happy we got to this point? So that is how we do that process, right? So now that you know how to find the standard deviation, let's do a couple practice problems just to kind of lock that down. Then we'll talk about how to apply that with what we call the normal distribution of the data.